Okay, so welcome to FM Tuition Academy. Okay, now if you know you're a grade 10, grade 11, 12, or a GCE student, okay, you're doing either maths, science, biology, English, civic education, that is CE, commerce, RE. Okay, if you are doing this, you want us to help you with online tuitions, you can WhatsApp us on this number 095 33 12 04 or 0979 22 20 76. You can WhatsApp us on either of those numbers, and then we'll be able to train you so that you can pass the ECZ questions. Okay, now today in science we are continuing, guys. We're looking at the part 2. Last time we did introduction to machines. This is part 2 of machines. Okay, machines or simple machines, but we're looking at part 2 now. Okay, now in the exam sometimes a question can come, they can say they can give you a diagram, like for example they bring a diagram like this and then they draw it for you like this, and then they can bring a diagram, it looks like this, where they draw for you maybe something like this. They put a pulley there and another pulley here. Okay, and then here inside they may bring one. Okay, let me draw another one outside here, 2. So even here I put 1, I can put 2. Okay, a pulley like that. I hope there'll be enough space. And then they may draw this line joining those 2 pulleys inside. Okay, then this other line will join this pulley and that other pulley. Okay, and then this other line join this pulley and this pulley. Okay, they are being joined like that. Okay, I hope it's easy to understand. Okay, it's this one, this is 1, so this is a string like that. I don't know if I've drawn it correctly. Did I draw it properly so that I don't confuse you? Okay, this is a string, it goes like this, joins that pulley, it comes my drawing is not well, so it comes, joins this pulley, it goes round on this, same way that side, it goes round and then joins with this pulley. Okay, you have seen. I'll use different colors so that you can see them. So that's the first one, it's joining the first pulley inside this circle and this circle. And then the second circle also has got its own string. It comes, joins again this pulley, it goes round, same this side, it goes, joins that pulley again, it joins this pulley this side. Okay, same again. Okay, I'll use a different color also there so that it's easy for us to understand. Okay, again this string joins this pulley, it goes round, the same string goes, joins this other pulley this side. Okay, like that, and then it is lifting something that is very heavy. This is like a box. Okay, this is like a box, and this box is weighing it's weighing how much? It's weighing 4,500 newtons, for example. Okay, and then okay, this side you have got a force of let's say 1,000 newtons. Okay, and then the question comes where they say question one. I'll write the questions inside. Question 1 is find the mechanical advantage. Find the mechanical advantage. That's the first question. So how do you solve the first question? We'll just start solving that I teach you. The first thing is you write the formula for mechanical advantage. Mechanical advantage is equal to, looking at the diagram, if you look at this diagram, it's given load. You see this load is pointing downwards, okay? It's heavy. This load over effort. So it means this is the effort. They won't tell you. This is the effort and this is the load. This is the load. So the effort is 1,000. The load is 4,500. So mechanical advantage is load over effort. So how much is the load? 4,500 newtons divided by the effort, which is 1,000 newtons. When you divide those, these two zeros cancel out, those cancel out. 4.5 divided by 10, it is 4 point what? Is 4.5. That is the answer. Mechanical advantage has no units, so it's just 4.5. That is question 1. Okay. Question B, from the same question, but now we're doing question B, guys. Okay, we're doing question B. So question B of the same question, how are you going to solve? Find the velocity ratio. Find the velocity ratio. Do you know there's something you need to know about the velocity ratio? The velocity ratio is equal to the number of strings. If you are given a diagram, the velocity ratio is always the number of strings. So I'm just trying to help you to understand. The velocity ratio is always the number of strings attached to the pulley. So the velocity ratio is the number of strings attached to the pulleys. Those are round things. So you come here, you look at your diagram. How many strings do you see attached? They look like parallel lines. So we'll start. So this is the first string 1. This is the first string 1. This is the second string 2. Okay, this is the third string 3, and then 4. Again this one 5. Again this one 6. You see I've counted them. I repeat. I'm counting the number of strings. This is 1. Okay, the ones that are coming to these round things. So it's 1. They are parallel. You just count them in this order, the way they are coming. So this is 1. This is 2. This is 3. This is 4. This is 5, and this is 6. That's how you count them. You count them in horizontal. Okay. Okay. So this is 1. This is the first string, and then second string this one. Again third this one. Again fourth this one, and then fifth this one. Again 6th that string. So there are 6 strings attached to these round things. Okay, those round pulleys. So 1, okay, 2, okay, 3, again 4 this one, and then 5 that string, and then 6. So it means the velocity ratio is actually 6. I was just teaching you. So it means the velocity ratio is actually 6. So 6 is the answer. Okay, that's how you do it. And then question C, from the same question, they can ask you, find the efficiency. They can say find the efficiency. So you should know that efficiency of this is mechanical advantage. You remember the formula? I think I gave you these formulas. The efficiency is equal to mechanical advantage over velocity ratio times 100%, times 100%, like this. So where do you know the mechanical advantage? You already calculated it. What is the mechanical advantage on top here? What is this mechanical advantage? We did this. You go into question 1. Mechanical advantage is this one, 4.5. We calculated it. So our mechanical advantage is this one, 4.5. So on mechanical advantage we put 4.5. Our velocity ratio is 6. So on velocity ratio we put 6. Okay. So our answer is mechanical advantage 4.5, which we calculated, velocity ratio 6 times 100%. Okay, which will give you what? 4.5 times 100, and then the answer you get divided by 6, it will give you 75%. Okay, 4.5 times 100, you put equals, and then the answer you get, you divide it by 6, it will give you 75%. That's how you calculate these ones. Okay, that's the answer. So these can come in a different way. That's how they come. Different ways. Different ways. Different ways. Okay, now let's look at, for example, they can bring this in a different way. Okay, you can be in the exam, they can bring it in another way. Okay, they can bring it in another way. For example, they can bring for you something like this. Maybe they put it like this. Okay, they put this thing like this, and then they put they can put for you that. Okay, let's see, what about if they bring for you like this? They put for you that, and then okay, let's say they bring for you maybe they bring for you something like this, and then even here, let's say they bring for you another one here. Okay, and then here again they can bring for you another one, even here like that. Okay, and then they can bring for you even one there, the other one here, and then even a box down here. They can put for you a box. Okay, a box, this box, and then they can put, so there are how many pulleys? So it is 1, 2, 3, 4, 5. Okay, I think 5 are enough. And then they can bring they can bring it can come like this. The string comes like this, and then it comes, let's say it joins this first pulley here, and then goes, and then it goes, and then joins that one, comes like this. Let's say it goes like this, and then it comes, it joins this one here. Okay, and then it comes, joins, yeah. So if I draw it like that, Yeah, I can do it like that. And then it comes, let's say it comes and then it joins like this, comes like this. How did I do it? Okay, it joins here. So it comes, it's the same one there, comes and then it joins again, comes, joins like this. Okay. Yeah, something like that. And then they ask you to calculate. Okay, let's say it's like this. Okay, and then here, the first question I give you, of course, this is the effort. Okay, this is the effort. Again, apart from that being the effort, that is the effort. And then I can say this load here, it is the, let's say this load is the, let's use the even 100 kilograms. The load is 100 kg. Okay. And then let me do the questions now. Question 1. Question 1 is state the velocity ratio. State the velocity ratio. Remember what I said the velocity ratio is? It's a number of strings that are parallel. Okay? Okay, just say the number of strings. Velocity ratio is the number of strings attached to the pulley. That's what I said. Velocity ratio is the number of strings attached to the pulleys. Okay, I've explained what that is. Velocity ratio is the number, I'm repeating again, number of strings attached to the what? To the pulley. I think I've explained this countless times. So you look at the diagram. How many strings do you see attached to these pulleys? I always say when you're counting them, you use perpendicular lines. So we have 1. Okay, I'm using a different color. How many strings are always perpendicular? So this is 1. This is the first string here. You see? 2. This string here. Okay. 3. That string there. 4. This string here. 5. This one outside. I'm repeating again. How many strings do you see? 1. This one outside here. 2. This one inside. Okay. 3 is this one here. 4 is this one this other side, and then 5 this one here. Okay, so 5 strings. Okay, 1, and then this one is 2, then this one is 3, and then this one is 4 string, and then 5 the other side. On the other side, they are vertical. Okay, so it means 5 is a velocity ratio. Okay, now a question can come saying, question part B of the same question, they can say, if the machine has the efficiency of, let's say, 70%. Okay, calculate the effort applied. They say calculate the effort applied. The first thing is, it means you have 2 formulas that you're going to use, because you need the formula for efficiency, okay, and you need the other formula which has got effort. So you write them separately so you don't get confused. Okay, so you need two formulas to calculate this. So the first formula is for efficiency. So you say efficiency is equal to mechanical advantage over velocity ratio times 100%. Okay, the second formula is the one that has got effort is the one for mechanical advantage. Remember that formula. So mechanical advantage is equal to load over effort. You need these two formulas. This is a formula that has got a load in it. Mechanical advantage is equal to load over effort. So you need these two to be able to calculate this. That's the only way. You need two of them. Okay? You need two of them. So mechanical advantage is equal to load over effort. So we're looking for the effort. So we'll start. Meaning first, the efficiency we have. What is the efficiency? 70. Efficiency is 70%. So on efficiency you put 70. So efficiency there you put 70% like this. And then mechanical advantage. Mechanical advantage is what? With velocity ratio is 6. This is velocity ratio. You remember there are 5 strings. So on velocity ratio here you put 6. And then we've got mechanical advantage, you do not know, it was not given. So mechanical advantage times 100%. Okay? So what do we have? We have got 70% is equal to 100% of mechanical advantage divided by 6. Okay, I think we have all done mathematics. Okay, when you reach here, you already know how to do mathematics, right? Mathematics, already know any number on its own is over 1. I think this is simple. Everyone knows how to do this, right? For you to find MA, so it will be 100 MA is equal to, so it will be 100 MA. 100 MA is equal to, what is 6 times 7? 6 times 7 is what? 6 times 7, you need to know 6 times 7. These are simple things, mathematics. So you multiply 6 by 7, what are you going to get? So 6 by 7 is supposed to give you like 420. Okay? But yeah, trying to make MA the subject. This is MA. So it means you divide both sides by 100, even that other side by 100. Okay? You divide both sides by 100, even this other side by 100. Okay? Okay. Okay, so okay, so meaning when you reach here, you divide this side by 100, even this side by 100. Okay, this 100 goes, this 100 goes. So meaning mechanical advantage is going to be what? Is equal to 100 divided by 420. What's the answer? 4.2. 42 actually. 42. It will be 42%. I mean 42. Sorry, not 42%. 42. Because the percentages will cancel out. Do you see this? Maybe you didn't see this. Okay, let me redo this part here down. Maybe you are confused. Let me take it the other side. This is going to be what? If we take it this side, it's going to be 100% again mechanical advantage is equal to 420%. Okay, and then he said we divide by 100% this side, so to remain with MA, even this side by 100%. So this cancel out. So it means mechanical advantage is equal to, of course, you already know this cancels out. You have done math. So this percentage goes, this percentage goes. What is 420 divided by 100? It is 42. Okay, is the answer. 42, not 42%, 42. Remember I said mechanical advantage has no units. So on mechanical advantage, you have got 42. So we'll come back to this formula. We're looking for the effort. But on mechanical advantage, you put 42. So it will be 42 is equal to the load. Okay, let me take this formula on the other side, so that you have got good space. Okay, I'll leave it here. I said, yeah. So, we said we found 42 as a mechanical advantage. So I'm looking for a space. I'll take that formula here. So we said mechanical advantage is equal to load over effort. So we said the load that we have found, the mechanical advantage that we calculated is 42% is equal to the load. We're looking for the effort. The load, what is the load? If you look at the diagram, the load is what? The load is 100 grams. But load is always calculated in newtons. So it means you're supposed to convert it to newtons. So it means the load is the same as the weight. Okay? Is the same as the weight. So it means weight is the same as mg, mass times gravity. So mass is, what was the mass for that weight? The mass was, you see, this one is not in newtons. If it was in newtons, we just speak it like that. It's not in newtons, it's 100 kg. If it was 100 newtons, we just write it like that, but it's kg. So to convert kg to newtons, we multiply by 10. Acceleration due to gravity. So it will be 100 times 10, which is gravity, is equal to 1000 newtons. That's the one that you put here. 1000 newtons. You divide by that. So it will be 42E, which is the effort, is equal to 1000. You divide by 42. You divide by 42. So you say E is equal to 1000 divided by 42 is what? So you calculate that 1000. You divide 42 into one pin. 42 divided by 1000 divided by 42 is 23. It is 23. 20. Yeah. It will be 23.8 newtons. Because the effort is in newtons. I said the load is the same as the weight. So weight, it is equal to mg. Okay, so this one, the one that you are seeing here, it's a load. Okay, that's why I put it on load here. Okay, 1000 on top on load, because the weight is the same as the load. Load is the same as weight. So the answer that you're looking for is 23.that. I hope your mind has really understood this. Okay, here you write two formulas first. You write that formula and this formula, mechanical advantage, load over effort. When you find the mechanical advantage, you replace where there's mechanical advantage, you put 42. And then you make L the subject. E the subject. E is E, effort, since that's what I'm finding for what I'm finding for. So you put E there and then you make E the subject. But for the load here, we found that the load was 1000 kg, not 1000 newtons. If it was 100 newtons, just put it here because it's already in newtons. But since it is in kgs, that's the reason why we converted it to weight. Weight is equal to the mass times the gravity, so that you multiply by 10, so that it becomes in newtons. That's the one that you put here. Okay, guys, I think we can do an exercise. Let me see if you have really understood this, because you need to practice. That's the only way you can become good. That's the only way you can become good. There's no other way. Without practicing, you cannot become good. So we'll try it out. Let's see if you're able to do it. If you don't manage, all right, there's no problem. But you need to try this, guys. because it comes in your exam. So that is 0. I mean, that's a pulley. That's a pulley. This is another pulley there. That is another pulley there. Okay, this is another pulley. Okay, so here there are 3 pulleys. Here down there are 2. So the first one goes qua. Second one, okay, I mean this is going like this, they go round up to that other side, okay, and then this one goes like this, goes round, oh boy, so it goes like this, picks this side, goes okay, to go like this, it goes like this, okay. Should have used a different color. I think you can see. So that, okay. And then the other one is like this. Not like that. So it goes like that. Yeah. Okay. So it just goes like this. Okay. 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 So it's already attached. I would have used a, actually, let me just use a red one so that you understand. So this is, it's also attached like this. It will go like this, then it comes attach itself like that. Okay. Yeah. Okay. Same thing. Okay. So how many strings do you see there? I told you pick the ones that are parallel. Okay, that's what I said. So question 1. Find the velocity ratio. So 1A. Find the velocity ratio. 1. B. Calculate mechanical advantage. Calculate the mechanical advantage. C. C is what, guys? What I'm going to do is C. Guys. C is okay. Actually, we use a force of let's say 1,500 newtons here, and then here we use a load that's been lifted as maybe a box that's been lifted here will be 20,000 or 2,000. Okay, 3,000 newtons. Let's use 3,000 newtons. Okay. You see, these ones are already in newtons. Huh? You don't need to multiply by 10. Only when they're in kgs, that's when you multiply by 10 to convert them to weight. But they're already in newtons, so there's no need. I think I've explained this. Okay. And then lastly is calculate the efficiency. Lastly is calculate the efficiency. Wow, guys, this is nice. This is question 1. These things, they come in the exam, guys, so please pay attention. Okay, so what are we gonna have? Okay, now this one is gonna be tough. It'll be tougher than the usual ones I've been doing, you guys. Okay, so it's okay. So this one has got this one is gonna come like pa. Okay, so it goes like that. It goes like that. Okay, so it goes like that. What do we do? We'll draw the first. It has got the first one there. Okay, like that. It has got the first pulley here. That's the first pulley. and then it has got a second pulley here. It has got a second pulley here. Of course, there's nothing there. Okay, like that's fine. So first pulley, second pulley, and then it has got the third pulley here. Okay, it has got the third pulley there, and then it has got another pulley here, and then another one there. Okay, and then so how many pulleys have I put? I put 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 is fine. And then it goes, so these two are also joined like this. So they're also like this. There's something like that. Okay, join this. Okay. Okay, so it goes like this. They're also joined like this. And then they've got a load down here which they are lifting. Okay. Okay, this load is let's say 200 kgs. You see, if it's kgs, meaning you have to convert to grams. I mean to newtons by multiplying by 10. I think I've explained this. I don't need to tell you again. Let me look at your effort, what you can do. Okay, let's see what we can do. So this thing goes like, it starts, okay, let me draw the strings now. So we see how best we can draw the strings. So the first string comes like this, so it comes there. This one comes straight, it goes like this, and then comes, where first does it come? So it goes down, so it attaches itself with this first one, it goes like this, and then it goes straight like this. Okay, so it goes like this, like this, like this, and then it goes, attaches itself to this second one, and then it goes like this, like that. Then it goes down. When it goes down, it attaches itself to the second one. So it goes like this, it goes down, 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 attaches itself to this one. Okay? And then after attaching itself to this one, it goes up again. Okay? So it attaches itself to that one, then it goes down, and then it attaches itself to this one. Like that. I think you can manage to draw that. So it goes wide, goes on top, goes down, goes on top. I don't know if you managed to draw it, but I think it's easy to draw. So here is so that is the effort. This is question 2. Let's look at the questions now. Question 1. Define a machine. That is question 1. B, effort. C, load. First you have to define them. That's the first question. Okay. Actually, these ones is not 1. This is 1, I, 2, 1, 2, 3, 3. So A1, A2, A3. Okay, B part B of the same question. State the velocity ratio. State the velocity ratio of the pool. Meaning you need to calculate it. You have what is the velocity ratio? I've taught you how to find the velocity ratio. I didn't say define, I said state. So it means you're supposed to calculate it. Tell me what the velocity ratio is. 6, 7, 10, 11, whatever. Tell me what the velocity ratio is. Okay. And then part C. Part C is define 1 efficiency, 2 mechanical advantage. Mechanical advantage. You have to define this. C. What about D, guys? D. Last one is now, this one is going to be tricky. It's similar to what I was showing in the examples. Okay, this one is when I use 2 or 3 formulas. If the machine, I think I've taught you this, you need to pay attention, guys. If the machine has the, if a machine has the, what did you say? A machine has an efficiency of, let's say 80%. I've taught you how to do this. Calculate the applied force. Calculate the applied force. Just for the example, the one I'm showing you, the applied. Calculate the applied effort. Okay, I told you use the formula that has got effort and the other one that has got efficiency. And you use the mechanical advantage formula and the efficiency formula. And then you start first with the efficiency. When you use the efficiency, you get the mechanical advantage. And then you substitute that. I think I taught you this, where I said now you convert the 200 newtons to 200 kgs to newtons. I think I've explained this countless times. I hope you really understood those. So guys, please practice this. Okay. So this is the end. Those ones who haven't hit the subscribe button, make sure you hit the subscribe button. Okay? You can hit the subscribe button, submit your exercise, and turn on the notification bell. Notification bell. Okay. Now do that exercise and submit.